Okay, so now we're going to go over the last conic section, the hyperbola 11.3, the hyperbola. So what exactly is a hyperbola? A hyperbola is the set of all points in the plane. The difference, instead of the sum as an ellipse, in a hyperbola it's the difference of whose distances from two fixed points, remember those two fixed points are the foci, is constant. So instead of the sum being a constant, the difference is going to be a constant. So a hyperbola has two branches, like two parabolas. It's either going to open right and left, or it's going to open up and down. Okay, if it opens right and left, the foci, just like in a parabola, they're inside. In a parabola, there's just one focus, one branch. In a hyperbola, there's two foci, one for each branch. So if you pick any point on the hyperbola, pf1 minus pf2 in absolute value is a constant. And what's interesting is if you have any ray of light that's going through the focus, if you have any ray of light that's hitting the hyperbola going to the focus, it reflects and goes through the other focus. Okay, this is used in corrective lenses and so on. So anyways, so we have a hyperbola that opens right and left, or it opens up and down, f1, f2. The line through the foci intersects the hyperbola at 2 points called the vertices. There's two vertices in a hyperbola, just like an ellipse, whereas there's just one in a parabola. Okay, so these are the vertices, v1, v2. The transverse, so there is no major and minor axis. There is no bigger and smaller axis. The axes could equal, but we don't know which one is bigger, which one is small. There's transverse axis, and there's a conjugate axis. The transverse axis is the line segment connecting the two vertices of length 2a. This is called transverse axis. Its length is 2a, and this is called transverse axis. Its length is 2a. The center of the hyperbola is the midpoint of the transverse axis. Center. It's the midpoint of v1, v2. It's also the midpoint of f1, f2. Center, midpoint of v1, v2, midpoint of f1, f2. Same thing, midpoint of v1, v2, midpoint of f1, f2. The conjugate axis is the line segment of length 2b through the center perpendicular to the transverse axis. So this is called the conjugate axis. It's through the center, its length is 2b, and it's perpendicular to the transverse axis. Same thing here. It doesn't have to be smaller, it could be equal or greater than the transverse axis. This is called the conjugate axis. Its length is 2b. So now the set form of the equation of a hyperbola, the standard form of the equation of a hyperbola centered at hk. It's going to be x minus h squared over a squared minus y minus k squared over b squared equals 1. If the negative is in front of my y squared, that means no y-intercept, so it's going to open sideways. Opens right and left, and transverse axis is horizontal, transverse axis is horizontal. So this is what we're talking about. This is the center, and this is the transverse axis. Its length is 2a, and would be y minus k squared over a squared minus x minus h squared over b squared equals 1. This would open up and down. Transverse axis vertical. Transverse axis center. It's 2a. If the center is 0, 0, if center is at 0, 0, then we have either x squared over a squared minus y squared over b squared is 1, or y squared over a squared minus x squared over b squared is 1. This opens right and left, this opens up and down. In a hyperbola, a could be bigger than b, could be less than b, and could equal b. In a hyperbola, you will see that c is bigger than a and it's bigger than b. So c squared equals a squared plus b squared. We can prove that, okay? So in an ellipse, it was a squared, the bigger value. In a hyperbola, it's c, that's the bigger value. So let's just make write important stuff here. Vertices, the two vertices are a units from the center. A units from the center. As always. Foci are c units from the center. And c squared equals a squared plus b squared, or b squared equals c squared minus a squared. In a hyperbola, again, c is always bigger than a and it's always bigger than b. So when we draw a hyperbola, you know, how do we know if it's narrow or wide? Narrow or wide. That's why we need what we call the asymptotes. Each hyperbola has two asymptotes. They're boundary lines that intersect at the center of the hyperbola. The asymptotes pass through the vertex of a rectangle of dimensions 2a by 2b with its center at hk. So basically, you find the a and the b. This is to get the asymptotes. So you say they're horizontal. So a, negative a, b, negative b. You make a box from these 4 points. The diagonals of the box through its center are called the asymptotes. So this is an asymptote, and this is an asymptote. They're lines through the center. In this case, I made the center 0, 0, but it could be anything. So the equation, you can remember the equation of a line, y minus y1, m into x minus x1. So y minus 0, the slope is b over a, x minus 0, and for this one it would be y minus 0. The slope is, you go up b to the left a, so it's negative b over a, x minus 0. And if it's h and k, then you put h and k, okay? And these are important because once you have the asymptotes, then if these are the vertices, then you go up and along, down and along. Or if it's here, then you do the same thing. So they give you don't need a t-table. They give you a direction as to how you're going to graph the hyperbola. So let's practice that. Number 10, page 805. Y squared over 9 minus x squared over 16 is 1. So it's a hyperbola, not an ellipse, because of the negative. So a squared is 9, a is 3, that's your y value. B squared is 16, b is 4, that's your x value. So let's make a box to get, and the center is 0, 0. So from the center, we go up and down 3. Those are the y values. And then from the center, right 4 and left 4. We draw a box through these 4 values to get the boundary lines or the asymptotes from one end to the opposite end. Extend it. Same thing here. A ruler might help. Has to be a straight line, unlike mine. And it's negative in front of x squared, so this is going to go up and down. This is the vertex, and this is the vertex. And this is 0, negative 3. This is 0, 3. So you start at the vertex and you go along the first asymptote and the second asymptote. Same thing here. Don't miss the vertex. That's the most important point on the hyperbola. Now to find the foci, we have a and b. We gotta find c. C squared is a squared plus b squared. 9 plus 16, 25. So c is 5. So the focus is 5 units from the center. It's going to have to be up and down because it has to be enclosed inside the hyperbola. 1, 3, 4, 5. So this is F1, 0, 5. 1, 2, 3, 4, 5. F2, 0, negative 5. And the equations of the asymptotes. Remember y minus 1, it's 0, m. For this one, as it's the a's and the b's. B is 3, a is 5. And then x minus 0, and for the second one, y minus 0, it would just be opposite slope. That's it, plus or minus b over a. Again, 3, negative 5. Okay. So how do we graph the hyperbola? 9x squared minus 25y squared is 225. Let's divide by 225. Put it in standard form, so that's x squared over 25 minus y squared over 9 equals 1. So a squared is 25. A is always the positive value in this case, okay? So that's an x. B squared is 9. B is 3. That's the y value. And again, center is at 0, 0. No h, no k. So we go 5 units sideways from the center. And then 3 units vertical from the center. We make a box. Diagonals through the center are the asymptotes. The equation of the asymptote with a positive slope is y equals 3 over 5x, and this would be y equals negative 3 over 5x. Now since we're negative in front of y squared, so these are the vertices. It's going to open right and left. So these are the vertices v1, v2. To find the focus, we need c. C squared is a squared plus b squared. 25 plus 9 is 34, so c is square root of 34. So we're going to go from the center. Square root of 34 is somewhere between 5 and 6, closer to 6. 1, 2, 3, 4, 5. This is 6, so f1 is root 34, 0. f2 is negative root 34, 0. Number 30, page 806. 30, page 806. Let's see what 30 is about. It says find the equation for the hyperbola whose graph is shown. So if you look at the graph, it opens sideways and its center is at 0, 0. So x squared over a squared minus y squared over b squared is 1. The vertices are at 2 root 3. You can see that 0 and negative root 3, negative 2 root 3 is 0. So the a's So a is 2 root 3, so a square is 2 root 3 square is 12. And what else do we have there? It passes through the point 4, 4, so this is x squared over 12 minus y squared over b squared equals 1. So the hyperbola passes through the point 4, 4, which is on the graph. So when x is 4, y is 4, that way we can find b. So 4 squared is 16 minus 4 squared is 16 over b squared equals 1. So 16 over 12 minus 1 is 16 over b squared. 16 minus 12 is 4 over 12, which is 1/3, equals 16 over b squared. B squared is 3 times 16 is 48. So x squared over 12 minus y squared over 48 is 1. Okay. Let's look at an example from 11.4. Section 11.4, x plus 3 squared over 16 minus y plus 2 squared over 25 is 1. So it's a hyperbola centered at -3, -2. A squared is 16. So this is an x value. B squared is 25. B is 5. This is a y value. And you can see B could be bigger than A. It's a hyperbola. So if we draw the graph centered at -3, -2, -3, -2, that's the center. The A's are 4 and the B's are 5. The A's are x, so we go from the center 1, 2, 3, 4. This is the vertex at 1, -2, and then 1, 2, 3, 4. This is the vertex 1, 2, 3, 4. So that's -3, -7, -2, and then we go. The B values are 5, so we go up 5 and down 5. 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. So we have a box. The diagonals of the box through the center are the asymptotes. So the hyperbola is going to open sideways because x squared is positive. We have a negative in front of y squared. The equation of this hyperbola, y minus -2, is m. Remember, m is rise b over a, in this case rise over run, 5 over what is it, 5, what was that, 11, a is 4 and b is 5, so 4 over 5, a is 4 and b is 5, so 5 over 4, x plus 3. This would be the same except the slope is negative. And the foci, so c squared is a squared plus b squared. A squared is 16, and then b squared is 25. So c squared is c is square root of 41. So they're gonna be inside. So we start at the center. So it's 36 to 49. So it's about 6.5. 1, 2, 3, 4, 5, 6. So it's around here. F1. The y value is -2, but the value you start at -3 and you move to the right root 41. Same thing here. 1, 2, 3, 4, 5, 6. So the focus is right here. The y value is -2, but the x value you move at start at -3 and you minus root 41 because you go to the left. Okay, number 40, page 806. 40, page 806. It says, find the equation of a parabola that satisfies the given condition. So now we don't have the equation, we need to find the equation. At 40, the foci is plus or minus 6, 0, and the vertices plus or minus 2, 0. So let's just take a quick look. The foci are 6, 0, and negative 6, 0. The vertices are 2, 0, and negative 2, 0. So the center, obviously, which is the midpoint of V1, V2, F1, F2, the center is 0, 0, and it's going to open right and left. So x squared over a squared minus y squared over b squared is 1. A is the distance between the center and the vertex, so a is 2. So a squared is 4. We still need b squared, but we have c. C is the distance from the center to the focus, so C is 6, so we use that formula. 36 equals 4 plus b squared, so b squared is 32, so x squared over 4 minus y squared over 32 is 1. Okay, here's another example. Now you can do that. I want to do one from 11.4, section 11.4. Again, we need the equation of hyperbola in standard form and graph. So write equation of hyperbola in standard form and graph. 4x squared minus 36y squared minus 40x plus 144y minus 188 equals 0. So we're going to do completing the square. So for that matter, we're going to group the x terms together and then the y terms together plus 144y and then the 188 to the other side. We have to pull out the 4 to complete the square, so it's x squared minus 10x. Pull out the negative 36, so it'd be y squared minus 4y. So we divide the 10 by 2, it's 5. 5 squared is 25. So we're adding 25, but we're adding 4 times 25, which is 100. We're adding, again, 2 squared is 4, but negative 36 times 4 is negative 144. So we're going to minus 144. X minus 5, x minus 5. Y minus 2, y minus 2. And that would be 288 minus 144 is 144. So x minus 5 squared over 36. Y minus 2 squared over 4 is 1. And finish it. It's in the notes on page 26 if you don't know how to do it. But I want you to finish it, okay? And that's it for chapter 11. We're all done with 11.1 through 11.4. We'll see you in chapter 12.